Hi, I'm Bob. Welcome back to the Introductory Econometrics course. We will continue our solutions to the computer exercises for Chapter 11, further issues in using OLS with time series data. We will find answers to computer exercises 5 to 13 today using Stata. Let's solve exercise 5. In part 1, add a linear time trend to the equation 11.27. Is a time trend necessary in the first difference equation? No, a time trend is not necessary for the first difference equation. Suppose there is a time trend in the level terms. The differencing will eliminate the time trend. We can verify it by adding the t to the model. The time trend is statistically insignificant at any reasonable level. In part 2, drop the time trend and add the variables WW2 and P to 11.27. Are these variables jointly significant at the 5% level? Adding the two variables to the model, we find they are jointly significant at the 10% level, but not at the 5% level. In part 3, add the linear time trend, Wooldridge, and P to equation 11.27. What happens to the magnitude and statistical significance of the time trend compared to that in part 1? What about the equation on P compared to that in part 2? Including the two dummy variables and the time trend gives the following results. The time trend becomes statistically significant now at the 5% level. The time trend effect becomes larger too. The coefficient on P becomes more negative and more statistically significant. In part 4, using the model from part 3, estimate the long-run propensity and obtain its standard error. Compare this to 10.19, where the fertility rate and personal exemption appeared in levels rather than in first differences. Would you say that the link between fertility and the value of the personal exemption is a particularly robust finding? We use the lincom command to compute the long-run propensity. It is minus 0.006, and it is statistically insignificant at any conventional level. The long-run propensity is statistically and practically zero. The 10.19 equation uses the level terms of fertility rate and personal exemptions and gives a statistically significant long-run propensity of 0.1. We know that the level terms are highly autocorrelated and suggest a unit root. The first difference terms are preferred, and the estimates from the first difference models are more reliable. The long-run link between fertility and the personal exemption is not robust. Let's do computer exercise 6. Let invent be the real value inventories in the United States during year T. Let GDP denote real gross domestic product, and let R3 denote the exposed real interest rate on 3-month T-bills. The exposed real interest rate is R3 equals I3 minus inflation, where I3 is the rate on 3 months T-bills and inflation is the annual inflation rate. The change in inventories is the inventory investment for the year. The accelerator model of inventory investment relates the change in inventories to the change in GDP, where beta 1 is greater than 0. In part 1, estimate the accelerator model, report the results in the usual form, and interpret the equation. Is beta 1 statistically greater than 0? We regress the change in inventory on the change in GDP. The estimate of beta 1 is 0.15, meaning that inventory is estimated to increase by $0.15 billion as GDP increases by $1 billion. The coefficient is statistically significant at the 1% level. In part 2, if the real interest rate rises, then the opportunity cost of holding inventories rises, and so an increase in the real interest rate should decrease inventories. Add the real interest rate to the accelerator model and discuss the results. We regress the change in inventories on the change in GDP and the change in real interest rates. The estimate for the coefficient on the change in GDP changes slightly and remains statistically significant. The coefficient on the real interest rate is not statistically significant at any reasonable level. In part 3, does the level of the real interest rate work better than the first difference? No, they give the same conclusion. We replace the change in the real interest rate with the level term of the real interest rate. The coefficient on the change in GDP changes a little and remains statistically significant, and the coefficient on the interest rate is statistically insignificant. Let's do computer exercise 7. One version of the permanent income hypothesis of consumption is that the growth in consumption is unpredictable. Let GC be the growth in real per capita consumption. Then the permanent income hypothesis implies that the information at time t-1 cannot help predict the consumption growth at time t. In part 1, test the permanent income hypothesis by estimating consumption growth on its first leg. Clearly state the null and alternative hypothesis. What do you conclude? The null hypothesis is that beta 1 equals 0. The alternative hypothesis is that beta 1 does not equal 0. The regression of consumption growth at time t on the consumption growth at time t-1 gives a statistically significant estimate of 0.45. It is evidence to reject the null hypothesis. In part 2, to the regression in part 1, add the disposable income at time t-1, the interest rate at time t-1, and the inflation rate at time t-1. Are these new variables individually or jointly significant at the 5% level? We can declare the time series data using the tsset command and then generate the first legs of the interest rate and the inflation rate. The result of the regression shows that the three new explanatory variables are neither individually significant nor jointly significant after controlling the consumption at time t-1. The p-values for the individual coefficients are 0.583, 0.507, and 0.416 respectively. The p-value for the joint significance is 0.232. In part 3, in the regression from part 2, what happens to the p-value for the t-statistic on the consumption growth at time t-1? Does this mean the permanent income hypothesis is now supported by the data. The p-value for the consumption growth at time t-1 is 0.145. It becomes individually insignificant. But we should find the overall significance of the model to test for the permanent income hypothesis. The F-statistic for the overall significance is 3.27 and its p-value is 0.0243. We reject the null hypothesis that all explanatory variables are zero at the 5% level. In other words, the data do not strongly support the permanent income hypothesis because the information at time t-1 helps predict the consumption growth at time t. In Part 4, in the regression from Part 2, what are the F statistic and its associated p-value for the joint significance of the four explanatory variables? Does your conclusion about the permanent income hypothesis now agree with what you find in Part 1? We have already answered this question in Part 3. Yes, it agrees with Part 1. Let's solve computer exercise 8. Estimate an AR1 model for the unemployment rate using only the data through the year 2003. Use this equation to predict the unemployment rate for 2004. Compare this with the actual unemployment rate for 2004. We estimate the AR1 model for the unemployment rate using only the data through the year 2003. The estimates are as follows. We plug in the unemployment rate for 2003 and predict the one for 2004. It is 5.94. The actual unemployment rate is 5.54. The AR1 model overestimates the unemployment rate by 0.4 points. In Part 2, add a lag of inflation to the AR1 model from Part 1, again being sure to use only the data through 2003. Is the inflation rate at time t-1 statistically significant? The inflation rate at time t-1 is statistically significant at the 1% level. In Part 3, use the equation from Part 2 to predict the unemployment rate for 2004. Is the result better or worse than in the model from Part 1? The prediction is much better than that from Part 1. The model overestimates the unemployment rate by only 0.06 points. In Part 4, use the method from section 6.4 to construct a 95% prediction interval for the 2004 unemployment rate. Is the actual 2004 unemployment rate in the interval? We generate two new explanatory variables and then regress the unemployment on the two variables. The intercept is the prediction. We can find its standard error and the 95% confidence interval. The 95% confidence interval is between 5.32 and 5.87. The actual unemployment rate, 5.54, is in the interval. But this confidence interval is for the average prediction. For a particular prediction, the confidence interval is wider. Using the formula in the textbook, it is from 3.92 to 7.28. The 2004 actual unemployment is, of course, inside it. Let's do computer exercise 9. In Part 1, compute the first-order autocorrelation coefficient for the variable of the percentage of accidents resulting in at least one fatality. Are you concerned that it contains a uniroot? Do the same for the state unemployment rate. The autocorrelation for the percentage of accidents resulting in at least one fatality is 0.71. The autocorrelation for the unemployment rate is 0.95. We are concerned that the state unemployment rate contains a uniroot because of its very high autocorrelation. Impact 2. Estimate a multiple regression model relating the first difference of the percentage of accidents resulting in at least one fatality to the same variables in Part 6 of Computer Exercise 11 in Chapter 10, except you should first difference the unemployment rate. Include a linear time trend, monthly dummy variables, the weekend variable, and the two policy variables. Do not difference them. Do you find any interesting results? We first difference the two variables and use them in the model. The estimates for almost all variables, including the two policy variables, are not individually statistically significant. In Part 3, comment on the following statement. We should always first difference any time series we suspect of having a uniroot before doing multiple regression, because it is the safe strategy and should give results similar to using the levels. The statement is false. The results are not similar between using the levels and the first differences in the regression models. When we use the level terms, the estimated coefficients on the unemployment rate and the speed limit law are statistically significant at the 1% level. Let's solve computer exercise 10. In Part 1, we estimate equation 11.19. Do the intercept and slope estimates change notably when we add the recent years of data? In the new dataset, we have 75 observations from 1948 to 2022. We use the tsset command to declare the time series data. Then we re-estimate equation 11.19. The time series operator, capital D dot, means the first difference. The estimate is minus 0.42. Statistically significant at the 1% level. The trade-off between unemployment and inflation becomes smaller than that using the first 58 observations. In Part 2, obtain a new estimate of the natural rate of unemployment. Compare this new estimate with that reported in example 11.5. The natural rate equals beta 0 hat divided by minus beta 1 hat. It is 5.77, slightly higher than that in the example 11.5, 5.48. In Part 3, compute the first-order autocorrelation for unemployment. In your opinion, is the root close to 1? The first-order autocorrelation is 0.71. It's not close to 1. In Part 4, use change in the unemployment rate as the explanatory variable instead of the level of it, which explanatory variable gives a higher R-squared. Using the change in the unemployment rate as the explanatory variable results in a higher R-squared, 0.175 versus 0.096. The trade-off between unemployment and inflation becomes larger. Let's find answers to computer exercise 11. Oken's law implies the following relationship between the annual percentage change in real GDP and the change in the annual unemployment rate. In Part 1, if the unemployment rate is stable, real GDP grows at 3% annually. For each percentage point increase in the unemployment rate, real GDP grows by 2 percentage points less. To see if the data on the US economy support Oken's law, we specify a model that allows deviations via an error term. In part 1, estimate the equation. Do you get exactly 3 for the intercept and -2 for the slope? Did you expect to? We don't expect to get exactly the same numbers, but the estimates are not far from it. In part 2, find the t-statistic for testing the null hypothesis that beta 1 equals -2. Do you reject the null hypothesis against the two-sided alternative at any reasonable significance level? We use the lincom command to do the t-test. The t-statistic is 0.6 and its two-sided p-value is 0.55. We fail to reject the null hypothesis that beta 1 equals -2 at any reasonable significance level. In part 3, find the t-statistic for testing the null hypothesis that beta 0 equals 3. Do you reject the null hypothesis at the 5% level against a two-sided alternative? We use the lincom command again. The t-statistic is 2.12 and its two-sided p-value is 0.04. We reject the null hypothesis at the 5% level against a two-sided alternative. In part 4, find the f-statistic and p-value for testing the null hypothesis that beta 0 equals 3 and beta 1 equals -2 against the alternative that the null hypothesis is false. Does the test reject at the 10% level? Overall, would you say the data reject or tend to support Oken's law? We use the test command to do the f-test. The f-statistic is 2.41 and its p-value is 0.102. We could not reject the null hypothesis at the 10% level. Overall, the data tend to support Oken's law. Let's do computer exercise 12. In part 1, find the first-order autocorrelation for the growth in the average wage in sector 232. Does this series appear to be weakly dependent? The first-order autocorrelation is tiny, -0.0349. It is likely to be weakly dependent. In part 2, estimate the dynamic model by OLS. Holding fixed last month's growth in wage and the growth in the CPI, does an increase in the federal minimum wage result in a contemporaneous increase in the wage growth in sector 232? Explain. Yes, a 10% increase in the federal minimum wage leads to a contemporaneous increase in the average wage in sector 232 by 1.5%. The effect is statistically significant at the 1% level. In part 3, we add the lag growth in employment to the equation in part 2. Is it statistically significant? The coefficient on the lagged growth in employment is statistically significant with a p-value of 0 to 3 decimal places. And notice that the minimum wage effect is almost unchanged. In part 4, compared with the model without the two lagged variables, does adding them have much of an effect on the growth in the federal minimum wage coefficient? we can store the estimates from the two models and then compare them in a table. Adding the two lagged variables does not change the coefficient on the minimum wage growth variable much. In Part 5, run the regression of the minimum wage growth on the two lagged variables and report the R-squared. Comment on how the value of R-squared helps explain your answer to Part 4. The R-squared is tiny, 0.004. The two lagged variables cannot explain the outcome variable. The federal minimum wage is almost uncorrelated with the lagged wage and employment. So when the two lagged variables are added to the model, it does not substantially change the coefficient on the federal minimum wage, although they are significant in the model. Let's solve computer exercise 13. The dataset includes monthly observations on vacancy rates and unemployment rates for the United States from December 2000 through February 2012. In Part 1, find the correlation between the unemployment rate at time t and t-1. Would you say the correlation points more towards a uniruled process or a weakly dependent process? The correlation is 0.9958, suggesting a uniruled process. In Part 2, repeat Part 1 but with the vacancy rate. The correlation is 0.9446. It also suggests the variable follows a uniruled process. In Part 3, the Beveridge curve relates the unemployment rate to the vacancy rate with the simplest relationship, where beta 1 is negative as expected. Estimate beta 0 and beta 1 by OLS. Do you find a negative relationship? Yes, we find a statistically significant negative slope coefficient. In Part 4, explain why you cannot trust the confidence interval for beta 1 reported by the OLS output in Part 3. The outcome variable and the explanatory variables are not stationary, weakly dependent time series. The assumptions for OLS consistency are violated, and the OLS statistics are not valid. In Part 5, if you difference unemployment rate and vacancy rate before running the regression, how does the estimated slope coefficient compare with Part 3? Is it statistically different from 0? The slope estimate becomes much smaller in size and not statistically different from 0. We find no relationship between unemployment and vacancy using the differenced variables. Thank you so much for doing the computer exercises with me. See you soon in the next chapters. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.